Hey everybody. Whoa, a little close to the mic on that one. All right. Are we ready for homework number 4, part the core problems? We're on to it. We're on to the core problems. All right, let's do this thing. Homework number 4, Math 1200, Denver University. What do you say? Time to get after it. Core problems. The function p of t equals 60 e to the power of 1.04 t describes the population of bacteria culture after t hours. What is the initial size of the bacteria culture? Okay, so the initial size means p at time 0 after 0 hours. So that's 60 e to the 1.04 times 0. 1.04 times 0 is 0. E to the power of 0, or anything to the power of 0 for that matter, is 1. So 60 times 1 is 60. And it doesn't specify what the units are here, but um or rather, like, is this millions or whatever it is, but it just says, which is interesting because later on they ask to include units. Um so 60, let's just say 60 bacteria, because I don't know. I don't know what they're looking for. 60 bacteria it is. B, find the number of bacteria in the culture after 4.5 hours. So P of 4.5. 60 times e to the 1.04 times 4.5. So we're going to plug her into the calculador. And we get 6466 bacteria. Now that's a little bit more reasonable, but still, bacteria are very small. I don't know how I guess they figured out how to start with only 60 bacteria. So, 6466. Find the rate of growth of the bacteria culture after 4.5 hours. Be sure to include units in your answer. Okay, so now, when it comes to rate of growth, that is our derivative, our rate of change, in other words. Change is growth. Growth is just a positive direction of change. If you change in a negative direction, you're shrinking, you're not growing. So P prime of T, okay, so anything with this overall form, e to the x or e to the t, the derivative is going to be as is, but it's going to be multiplied times the derivative of the exponent. And we covered that in, I believe, part 1 of this video. So it's going to be 60 e to the 1.04 t times the derivative of 1.04 t, which is just 1.04. So p prime of 4.5 is going to be 6466 times 1.04. And with that, wah, wah, we get 6725 bacteria per hour. So that's in this case why the unit is important, because it's distinguishing the rate of growth per hour, the bacteria per hour. Great. Part D, if there's a D. When will the population reach 60,000 bacteria? So we're saying that the population at some time t is equal to 60,000, which is equal to our 60 e to the 1.04 t. Okay, so which means if we divide both sides by 60, we have 1,000 equals e to the 1.04 t. And then we can take the natural log of both sides. So we have ln of 1,000 equals the natural log. I'm going to do this step by step. 1.04 t. Okay, and whenever we have an exponent inside the argument of a logarithm, that can come out as a coefficient. So we have 1.04 t times ln e, and ln e is equal to 1. So we have ln of 1,000 equals 1.04 t. So then we can say t is equal to ln of 1,000 over 1.04. And we get 6.64 hours. So I was just taking a look at this note here in the core problems, especially at the end where it says, well, I okay. The following problems will be graded for accuracy. Your solution should be written neatly and carefully and include all steps taken to find the solution. That part, I kind of naturally go through all the steps. I tend not to skip steps, so I try and go through the explanation of that. So that should serve you there, especially this like that right there, where you're taking the natural log of both sides without kind of just jumping to the 1.04 t. Um, so all that to say, hopefully, hopefully that these solutions are not only sufficient but also neat enough for you to follow along to and see how you can, organize your thinking and your steps. I was shocked to see you should not submit the first draft of your homework of it. And I thought to myself, oh my goodness, I am so glad that I never thought to submit or to have multiple drafts of my homework. I think that part of me is just I don't want to do that, so I take extra care to do it right the first time and to do it neatly as neatly as possible at least. Okay. So last homework and our last problem of the homework, and then we're on to homework number 5, and I'll see you in that one. All right. Consider the following function. F of x is equal to ln of x plus 2 times 2x plus 1 cubed over x squared. Okay, I'm considering it. Simplify the function as much as you can using logarithm properties and then compute the derivative. Hint, use your answer from A. Okay, so f of x. So if you recall from our previous discussion on how to do the logarithms, we can separate, if we have one single argument here, as we do, if you have inside the argument a quotient and or a product, you can separate each of the terms of the quotient slash product into their constituents and give each constituent its own ln. So what that means in practice is ln of x plus 2 plus ln of 2x plus 1 cubed minus ln of x squared. Okay. And then we're going to go through one more draft here. The first one's going to stay the same, ln of x plus 2. But now that we have this cubed, we just talked about that. If you have an exponent inside the argument of a logarithm, that can come out as a coefficient. So we have 3 ln of 2x plus 1. And then same thing with this x squared. We can make that minus 2 ln x. Okay. And I'm not going to go through the full like explanation of why that is. We talked about it in a previous video. So f prime of x, now we're taking the derivative. So this is a. Now we're taking the derivative of a. So that's b. The derivative of just ln x is 1 over x. So we're going to take that same format for each of these. So it's 1 over x plus 2. And whenever it's anything other than x, remember we have to consider the multiplying it times the derivative of the inside. But in this case, derivative of x plus 2 is just 1, so we don't have anything extra there. So the next one, plus 3 times 1 over 2x plus 1. And then again, we multiply times the derivative, so that's 2. And then minus 2 over x. And that's it. And we can simplify it so that it's just one fraction for the middle one. Plus 6 over 2x plus 1 minus 2 over x. Boom. All right. And that is homework number 4, part 2. Thanks for watching, and I will see you in number 5.